Okay, so I'm going to try and record how to make a DNA gel. So it's super zoomed in, but it's the best I can do. We're at the scale, have a bottle of agarose. Up above there are the weigh boats. So first thing you want to do is tear out your weigh boat. Make sure you close the sash on the side of the scale so it evens out. Alright, so then you tear. Now I'm going to make a 1.8% gel. So that means I'm going to measure out 1.8 grams of the agarose and dissolve into 100 mils of the TAE buffer. It's kind of hard to do with one hand, but alright. Alright. It's close enough for what I want to do. Right now it's measuring in milligrams, but that's 1.8 grams. So I'm going to take about out. Make sure you close the sash when you're done with the scale. Now we're going to go over to where we cast our gels. And actually I need to grab an Erlenmeyer quick. Another good thing. So all of our clean glassware we keep out in the hallway. So if you ever need to get yourself glassware, these 3 cabinets are all ours. The first one has most of the glassware in it. And I need to get a 250 ml Erlenmeyer. One of these guys. Alright, so this is the DNA station. It's kind of a mess right now, but the idea is that we're going to take off the tinfoil. Tinfoil with the little tape with stripes on it means that it's been autoclaved and that it's clean. This is hard to do with one hand. Alright, so I'm going to pour in my agarose. And then I have a 100 ml graduated cylinder. I'm going to measure out 100 mils of TAE buffer. So TAE, we keep up top, stands for tris, acetic acid, and EDTA. Those are the components of our DNA run buffer. We have 2 bottles. Make sure you grab the one that says 1X, which means it's working concentration. We also have a 50X up there, which is our stock to make more of the 1X. So if you ever tap out one of these bottles, just pour more. Alright, so we're going to pour up to 100. Hopefully we have enough in this. Why you gotta be like that? Alright, so that's like 90 mils. That's why we have 2 bottles. So when I'm done, I'll remake a 1X. Alright, we'll tap this up to 100. A little too much. This is the same thing as the run buffer in our tray, so I'm just going to pour off the excess into the run tray. And that's almost 100. Alright, so I'm going to pour in all 100 mils to our Erlenmeyer. Give it a gentle swirl just to make sure all the agarose is up in solution. And then we have a lab microwave up here. And I'm going to microwave the solution for 2 minutes and 20 seconds so that the agarose melts. Okay. All right. and we'll come back after that. Okay, so the auger's done microwaving. I'm gonna put on one of these fancy heat gloves so that I don't hurt myself. Now what I like to do, as soon as I take it out, I just kind of get it by the neck of the bottle and give it a swirl. Sometimes the solution can start to immediately bubble and boil, and I'd rather do that inside of the microwave rather than out in my face. Alright, and you can kind of tell it's not fully dissolved, there's little bits of agarose still in there. So what I'm going to do is just set a stir bar down inside, and then we'll bring it over to our stir plate and set it to about medium, and we'll let it spin for about 10 minutes. This will fully dissolve the agarose and cool it down a little bit before we add our staining agent, which is ethidium bromide. Alright, so the gel's been spinning about 10 minutes now. It's cooled enough that you can touch it without having to immediately pull your hands away. So the next thing we're going to do is use a P10 pipette to add 2 microliters of ethidium bromide to the gel. This will be our staining agent. The bromide we keep up here, this really dark colored solution. It's also a carcinogen, so I'm actually going to pause the video while I do this so I don't get it all over myself or the phone. Okay, so I've added the bromide, ethidium bromide, let it spin about 40 seconds just to get it mixed in well. And then I'm going to bring it over to our gel casting tray. So this has 3 parts: base, the casting tray itself, and our ladder wells. So what I'm going to do is just gently pour it in, and I'm going to watch the top of the wells and leave a little bit of space there so that it's easier to remove the comb after everything's hardened up. It's like right about there is where I'd stop. I did see kind of a chunky piece come out, so what I usually do is just take a single pipette tip and kind of push that chunks and bubbles towards the edge of the gel I don't use, the side towards me. And now that's going to sit for about like 20-25 minutes. You'll actually see it become more like opaque colored, and that's when you know it's ready to go. So it's been about 20 to 25 minutes. You can see the Erlenmeyer that had our excess has kind of turned into this real cloudy color, and it's also solid. And it's harder to tell, but so is our gel. So what I'm going to do is transfer the dried gel to our running tray, and then that might be where I end it because it's going to be really hard to record how to add samples with one hand, but you can always ask me questions for that part. So to disassemble this, there's a latch here that I tightened when I made the gel. I just loosen it up, and then this whole wall kind of wiggles away. Now before you go and pull your gel up, make sure this latch is not overhanging it, because I've pulled up and then hit that and ruined my gel before. So it's just good practice to get that out of the way. So there's our completed gel. You can tell it's nice and solid colored. We have 2 run trays. They're completely identical. It doesn't matter which one you pick. I'm just going to use this one. It already had run buffer in it from a previous experiment. If you are not sure about the buffer, you can always dump it out and put in fresh buffer. Buffer's cheap. Okay. And the buffer we use is the same thing we diluted our agarose powder into, which is the 1X TAE buffer. So, let me show you how to remove the comb. So I get it finger and thumb on each end and just very gently wiggle back and forth. Since I'm doing it with one hand, I'm putting a little bit of pressure on the casting tray so that the whole gel doesn't pull up with me. And the more patient you are doing this, the better results you're going to get. If you just rip it up, you have a very high chance of ruining your welds. So I kind of wiggle back and forth, push up and down a little bit. It definitely fights you while you're doing this. but you can see a little bit that it's giving. Every little time it comes up a little higher. And you can feel it getting easier and easier to pull. It's almost there. If you can try and get a little bit of the run buffer into the wells while you're doing this, it's easier. And there's a little bit more give. Alright, it's coming out right now. Okay, so before I do anything, I inspect the gel, especially the wells, to make sure I didn't damage them when I was removing it. So, this is a 15 well comb, which means I have 15 wells in the gel. I can tell that these wells are filled with buffer, but that's kind of something you get from experience. It's always a good idea just to tap it off a little bit to make sure that there is running buffer within the well itself before you add your samples, because that can really damage your end result in imaging the gel. All right. I'll try and load the ladder just to show you what it looks like. So over here I have my ladder on the left and 9 samples. I'm using the 100 base pair ladder, which is good for resolving small fragments of DNA. And I'm gonna add 10 microliters of that. So I'm just gonna grab D10 again, bring it up to 10 microliters. Sorry if the camera goes out of focus. It's usually when I'm looking at what I'm doing. Alright. So I've got 10 microliters in my pipette. Now, the way I do it, it's hard to show on the camera, but I would use my left hand to touch right about here on the pipette and stabilize myself. This way it's a lot easier to drive the pipette, because you don't want to miss. I have no idea what this looks like on the camera. Hopefully it looks alright. So you want to eject slowly, and gradually it'll kind of settle into the well. The dyes that we stain our DNA with have glycerol in them, which is denser than water. So it'll actually settle into the wells. You don't really have to worry about your sample getting blown out if you're slow when you pipette. And then, just as good practice, when I've pipetted something, I will move the sample away from my normal lineup. So like, say I pipetted that sample, I would move it out of the ones that need to get done. This way I know what's been put in and what hasn't. All right. So let's say I've loaded all my samples. What I would do is I would bring down the top. You want to make sure that your samples are on the black side of the gel, the black anode. And then there's also an arrow right here that shows you which way your samples are going to run. So they run from left to right, black to red. I'm going to set the top on just as an example of what it looks like. And then, following the wires up, we have a control box up here. So to adjust the voltage, make sure it's set to voltage. Push the arrow up once. So the previous user had set this to 90 volts. That's fine. If I was ready to set my samples off, I would just hit this running icon. And then, let's do it just to see if I can show you the bubbles. So the first thing to do is just look to make sure you don't get an error, because if there's a bad connection, it'll say E1. Then come back down and look into the left side. You can see those little bubbles forming. That's a sign that you have a good connection, that the samples are running. I'm going to kill it because I need to still put my samples in, but that's basically the idea. And then when you're done, disassemble the tray, put it onto the black imaging plate, which is over at the gel dock, and it'll take a UV image automatically for you. and that's how you make a DNA gel.